Okay, so we're still talking about system of equations. Remember last week we did them using the substitution method. So today it's just called the elimination method. It's a different method, but it will get you the same answer. So if we took all the examples we did last week and used this method, it's going to be the exact same solution. Okay? So this is just kind of a reminder of what a system of equations are. Okay, we're looking for the ordered pair where they cross, the one point that they have in common. So if we solve both of these and get the ordered pair, it should be the same as if we graphed it and saw where it crossed. Okay, so let's graph it and get the solution that way. So what are my steps of solving an equation, or graphing an equation?
Plot the intercept.
Okay, plot the intercept, so go to -3. Okay, then use what?
Your slope.
Your slope. So up 2 over 1. Up 2 over 1. Okay, so there's my first line. Okay, so do the same thing with the second one. So start at 2, and then a -1/2 slope. So down 1 over 2, down 1 over 2. So their point of intersection was 2, 1. Okay, so no matter what method we use, whether we use substitution or elimination, we should get the point 2, 1 as our solution.
Hey, this is easier than the other one.
So where did you get the 1 from?
The 1 was just that point. 2 over 2 up 1, that was where they crossed.
Is there not an equation where you just solve that just to get 2, 1 instead of having to
Yeah, it's called the substitution method or the elimination method.
There's something easier than the other method.
Okay, this is easier than the other method.
Okay.
The other method?
Well, we haven't got to the elimination method yet. So let's go to the first example. Remember, these are the steps, so you can always go back and remember just step by step for every equation. It'll work if you follow the steps. I feel like y'all will like this. I like substitution more, but I feel like y'all might like the elimination more. Okay, so what you do is this. Okay, so I'm going to take my equations and put them in columns. Okay, so I'm going to put the x's in a column, okay, the y's in the column, and then our numbers, okay, our constants. Okay, so that's what step 1 says. It says rearrange each equation so the variables are lined up in columns. Okay, easy enough. The second step is verify that one of the variables will be eliminated. Okay, what eliminated means if I add down that column, one's going to cancel out. Okay, so here I have -2x plus 1x. Okay, that gives me a -1x if I added down the column. Okay. If I do positive y minus y, that cancels out. It eliminates, hence the name elimination method. Okay. So y minus y just gives me 0, so I'm adding 0. Okay, equals 0 minus 5 would be -5. So now I know what negative x is. Okay, so I solve for x. So I divide by -1 to get rid of that negative sign. So I get x equals +5. Okay, step 4, just like we did in the substitution method, we take what our x value is and plug it in. We substitute it. So we say 5 minus y equals -5. So we solve for y. -y equals -10. Divide by -1, divide by -1. So we have y is equal to 10. Then step 5 is the same as it was in elimination. You write these solutions as ordered pairs. So our solution would be 5, 10.
This is easy.
Okay, we'll do a couple of them.
So we always line them up?
Always line them
one?
up for step 1.
Now, could you do this with that kind of equation?
Yes, we'll get to that. get to ones that don't necessarily already eliminate in just a minute. We'll do a couple examples where they already eliminate, and then a couple where you have to change it a little bit.
So you can do this way instead of the way we did last week.
Yes,
and
if you
we
do
can
both ways, they'll get you the same answer. So later, tomorrow, we will do an activity where you are advertising one of the methods. So you say, I think this one's easier, and I'm going to tell you why, and do a presentation over which one. Okay, so this next example, they're already lined up for me. So I have the x's in a column, the y's in a column, and then our numerical values in a column. Okay, so we're going to add down because we noticed that 3 minus 3 gets us 0. It eliminates. Okay, so we're good to go. We can go to step 2 and add it. Okay, so 6x plus 3x is 9x. 3y minus 3y, that eliminates. 15 plus 12 is 27. Okay. So that finishes step 2.
And then you just
Step 3, we divide by 9 to solve for x. So x equals 3. Then step 4 and 5 are exactly like substitution. Okay, we plug x back into one of the equations. It doesn't matter which one. Okay. And we get y. So we have 3. We don't want to put x. We want to substitute that in. Times 3 minus 3y equals 12. So now, to finish step 4, we solve for y. Subtract 9 from both sides to cancel. Negative 3y equals 3. Divide by negative 3 to cancel that. Negative 3 being multiplied times y. So we have y equals negative 1. So step 5, write our solution as an ordered pair. 3 comma negative 1.
Okay, at the beginning you're saying something about how the plus, like, you're saying, like, something about how if you can't do this, you can't add 6 plus 3 or whatever. Can you never subtract it?
You're always going to add. So you're always going to add down the columns, but the first thing you need to check after you arrange them in X column, Y column, number column, then the first thing you're going to check is to see, is there a variable that eliminates? If there is, then you add. Okay, if there's not, which is what I'm going to show you right now, you'll have to do something to those equations.
Are you talking about where there's no numbers by the x's?
Will there ever be any ones that you have to do a certain way?
No.
So
Sometimes different equations or systems are easier to solve a certain way, but you can do either way for any system. You can choose every time. Okay. All right. So are these lined up in columns? X, Y, and numerical value? Yes. Okay. So we can go on to step 2 because it's already arranged in columns for me. Okay. But step 2, verify that one of the variables will eliminate. If I added down those columns, will any of those eliminate? No. Okay. So what I want to do is make sure one does. In order to do that, so I'll take this x for example. X plus x is 2x, but I want it to equal 0. I want it to cancel out. So I need that x to be negative. Okay. In order to do that, I can multiply that entire equation by negative 1. Okay, remember, if I do it to one variable, I have to do it to everything in the equation. So I have x plus 4y equals 6. Okay, I didn't change the top one, but then I changed the bottom one. So I'm essentially distributing this negative 1 to every part of that equation. So I have negative x minus y equals negative 3. Now I have a column that eliminates. So we can go finish step 2. X minus x is 0. 0, so that eliminates. 4y minus 1y is 3y. Okay. And then 6 minus 3 is 3. So step 3, solve for y. Okay, we could have chosen either variable to solve for. We just chose x because they were both 1s.
But 3 divided by 3. 3 divided by 3.
Sorry, 3 divided by 3 is 1.
What I thought for that.
Not 3. Okay, so y equals 1. So we plug it back in up here. So x plus 1 equals 3. Okay, so I plugged it back into that equation. So solve for x. X equals 2. So our ordered pair, our step 5 is writing it as an ordered pair, would be 2, 1.
We might need a little more practice on this one.
That's fine. We got a few more examples. So I'm going to go through on this one and I'm going to label the steps. So I'm going to say step 1, this is what we did. Step 2, this is what we did. Okay. So they're already in columns for us. So step 1 columns are already done. So I'm going to put a check. Step 2, eliminate. So are they already in a position for us to eliminate a variable? No. Okay. We can't just multiply by -1 this time because we still wouldn't have anything that cancels. So what would be the logical thing we need to multiply by? Say I wanted to cancel that y.
2.
Not 2,
Negative.
-2. Because if I did 2, it'd be 2 plus 2 is 4. I want them to cancel. So I'm going to multiply by -2, that entire equation.
So you always have to have something cancel?
Yes, in order to do this elimination method, you have to cancel something. You have to have something to eliminate. Okay, so I didn't mess with the first equation. Okay, but I multiplied by -2 on the second one to make -8x minus 2y equals -40. Okay. So now the last part is to add. Okay, add down the columns. So I have 6x minus 8x is -2x. Okay, we got those to cancel. Equals -36. Okay, so step 2 is done. Step 3, divide, so solve for x. Divide by -2. X equals 18. Okay, step 4 is the same as in substitution. So we're substituting sub 18 in for x. So I'm going to choose the first equation. So 6 times 18 plus 2y equals 4. Subtract 108 over. 2y equals -104. And then divide by 2. So y equals 52. Okay, so step 5 and our final step, just write as an ordered pair.
Would it be -52?
Yes, thank you. So it'd be 18, -52.